Okay, hi everyone. Welcome to the third installation of our history presentations focusing on the search for extraterrestrial intelligence. For those of you who have been to the previous two talks, you'll know me, a familiar face by now. But for those of you who don't, my name is Rebecca Charbonneau. I am a historian of science and author of Mixed Signals, Alien Communication Across the Iron Curtain, which is a book that focuses on how the search for extraterrestrial intelligence developed out of the Cold War. In the previous two series, we've really kind of unpacked the origins of our search for life elsewhere in the universe, focusing especially on how that search was kind of embedded in the Cold War culture, how radio telescopes that were used for searching for artificial signals from space were also being used for things like nuclear missile tracking. In our last session, we looked at the first false alarm in the search for extraterrestrial intelligence, where Soviet scientists in 1965 thought that they detected evidence of a super civilization, but actually had just discovered a quasar, which is a very radioactive galaxy in the very distant universe. But today we're going to bring it up closer to the present day and talk about what scientists are doing now to search for extraterrestrial intelligence. We're going to start with a little bit of a background on how NASA got involved in SETI in the second half of the 20th century, and ultimately how SETI came to be defunded before having a little bit of a rebirth in the 21st century. So to start, I will tell you a little bit about this project, which is called Project Cyclops. So in the 1970s, SETI, again, was really just beginning to take shape as a scientific field, and NASA wanted to know what it would take to actually carry out a large-scale search for extraterrestrial intelligence. So they invited proposals from a large number of scientists and engineers, including SETI pioneers like Barney Oliver and John Billingham, and bring them together to kind of imagine what like the ultimate SETI instrument would be, just to see if kind of NASA would want to get involved. And they came up with this idea, which they called Project Cyclops, which was a vast array of about 1,500 radio dishes, each 100 meters across, all linked together into a giant radio telescope spread over several miles. The name Cyclops came from the idea of creating like this one big enormous eye that could be used to scan the heavens. And in theory, this array would have been sensitive enough to detect radio transmissions from thousands of stars across the galaxy, even signals as faint as like our own television broadcast signals, if they were sent from nearby stars. And this is a picture of what it would have looked like. This is a schematic from Project Cyclops, kind of like this massive instrument designed specifically to look for evidence of ET. But there was a catch, and that was the cost. In the 1970s, Project Cyclops was estimated to require the equivalent of today about $10 billion, a price tag that made it pretty much politically impossible. And so it was never built. Nevertheless, the Cyclops report became kind of a blueprint for future SETI efforts, and you're going to see that throughout today's talk. It laid out the technologies, the search strategies, and even kind of the cultural challenges of such a program. Many of the ideas it proposed, like the idea of using arrays of small dishes instead of just a large single one, eventually influenced later projects such as the Allen Telescope Array, which I'll tell you about in a bit. So in that sense, Project Cyclops was really less about building a specific instrument and more about setting this long-term vision for the search. But this is one of the defining features in SETI's history, which is its struggle for funding. Unlike other areas of astronomy that can promise steady discoveries, right, like new galaxies, new black holes, new exoplanets, pretty reliable, SETI has always been seen as a fairly high-risk investment. And that's because success is essentially all or nothing, right? Either we detect evidence of extraterrestrial intelligence or we don't. And that has made it pretty difficult to convince governments to commit to long-term funding, since each year that passes with no signal yet or no evidence of ET yet can look to outsiders like a failure. It's kind of inherently, it's a multi-generational problem. And this challenge is compounded by what's often referred to in SETI as the giggle factor. To many policymakers, SETI has sounded a little bit too much like science fiction, like exciting but not like completely serious compared to other pressing scientific missions, like looking for gravitational waves. And as a result, budgets for SETI have always been tiny compared to the scale of other NASA or National Science Foundation programs, and vulnerable to cuts whenever political winds shift. And because of this fragility, individual personalities in Congress could make or break the program. And so that brings us to one of the most famous moments in SETI's funding history. And you can see this man here on the left named William Proxmire. He played a significant role in singling out research that he thought was wasteful government spending. And SETI, unfortunately, became one of his favorite targets. One of the most notorious episodes in SETI's funding history is Senator Proxmire's Golden Fleece Awards. So back in the 70s and 80s, during a lot of fiscal budget cuts, these were kind of a publicity stunt that was created by Senator Proxmire. Every month, he would single out a government-funded project that he considered wasteful or ridiculous, and he would give it a Golden Fleece Award, and he would publish these and promote them in his office. And it was meant to expose what he saw as frivolous spending of taxpayer dollars. In 1978, NASA's plans for SETI that were building off the Project Cyclops initiative became one of Proxmire's targets, and you can see it there outlined in red. As you can see, he attacked NASA for proposing to spend about $14 to $15 million over the course of 7 years to search for extraterrestrials. Now, to put that into perspective, that amount at that time was a tiny, tiny fraction of NASA's overall budget, far less than the cost of most spacecraft missions, which tend to be most expensive. But once that label of Golden Fleece was applied, SETI was branded as silly and wasteful in the eyes of Congress and the public. It had a powerful ripple effect. It reinforced the idea of the giggle factor, that SETI was more science fiction rather than serious science, and it made it much harder for researchers to defend their work. Even though many scientists recognize SETI as legitimate and forward-looking field, one that might take a long time, again, kind of that multi-generational issue, politically it became a liability. Senator Proxmire himself dismissed NASA's program with kind of a punchline, saying it should be postponed for a few million light years. For those of you who are more science-minded in the group, you'll see the problem with this quote, which is that light years are a unit of distance, not of time. But Senator Proxmire wasn't exactly going for scientific literacy here. But lines like that got laughs and headlines, but they also legitimately chipped away at SETI's credibility in Washington. So scientists, of course, pushed back. Frank Drake, as we've heard his name a lot the last couple talks, one of SETI's founders. He actually, kind of in a rebuttal, nominated Proxmire for membership in the Flat Earth Society, highlighting what he saw as the senator's short-sightedness and, again, lack of scientific literacy. Drake also famously made the papers by comparing SETI to the mission of early colonial voyages, saying that when Christopher Columbus left Spain, there was no evidence the New World existed, let alone Wisconsin, which is the state that Proxmire was the senator of. But in other words, the absence of evidence isn't evidence of absence. And, inherently, exploration requires vision and risk. So while the Golden Fleece Awards may look like a little bit of political theater, for SETI they had very real consequences. They hardened already established skepticism, pretty significantly weakened NASA's support for the field, and ultimately helped pave the way for the cancellation of federal SETI funding in the early 1990s. So this one joke award really shaped the trajectory of an entire scientific field. Uh, Nevertheless, despite these political setbacks, SETI scientists showed remarkable perseverance. In fact, About a decade later, NASA did manage to launch one large-scale SETI project. It's called the High Resolution Microwave Survey. Kind of appropriately enough, riffing off of Frank Drake's comments a decade before, the observations actually began on Columbus Day in 1992. And you can see there from this poster on the right that the scientists really kind of had fun with this idea. It's like from 1492 to 1992, kind of symbolizing the start of a new era of exploration, this time, into the galaxy rather than across oceans. But ultimately, it was the first major SETI program funded by NASA. This is another poster from that project. The survey used some of the most powerful telescopes in the world, including the Arecibo telescope that we've talked about, which is in Puerto Rico, to carry out both wide sweeps of the sky. So basically, it's called a sky survey, where you just kind of look at the whole sky and see if you notice anything strange. And then also targeted searches of nearby sun-like stars, hoping that those would have a higher probability of having evidence of ET. It was certainly the most ambitious SETI effort ever attempted. And again, for the first time in 1992, the US government was putting significant resources behind the search. But unfortunately, it did not last long. After just about a year of operations in 1993, Congress pulled the plug under continuing pressure from the critics. An amendment to the 1993 congressional budget explicitly removed SETI from NASA's mission, meaning that they could not fund any SETI. And Senator Richard Bryan from Nevada kind of summed up the mood in Congress at the time by saying, this will hopefully be the end of Martian hunting season at the taxpayers' expense. So that statement really captured, again, the problems that this field was facing at the time. In the eyes of critics, SETI was lumped together with science fiction, UFOs, little green men, rather than being seen as a legitimate branch of astronomy that was asking a serious question, like, are we alone in the universe? And using the tools of science to try to answer that question. But the ridicule stuck, and NASA has kept its distance actually ever since. Even today, NASA does not support any SETI programs and generally does not solicit proposals for SETI projects from astronomers. Why? Well, there are several reasons for this defunding of SETI, and they reveal a lot about how politics and perception shape science. So first, there was what we've already discussed, the giggle factor. Many politicians and members of the public thought that the idea of searching for aliens sounded unserious, and it made SETI an easy target when budgets were being cut. Another challenge was the perception, again, of SETI as being all or nothing. Because the goal was to detect intelligent life, success could only be measured in terms of finding it, or not finding it. Unlike other space science projects, where discoveries naturally kind of happen incrementally, SETI really appeared to decision makers as either like a jackpot or a failure. So that meant that every time, institutional bodies like NASA had to request renewed funding, it kind of looked like the scientists were asking for more money despite producing nothing. Even though in reality, they were doing things like refining methods, ruling out false positives, and conducting, research that helped us understand the nature of artificial signals in our galaxy. There had also been a misunderstanding about how much had actually been searched. Politicians would sometimes invoke what's called the Fermi paradox, which I've brought up in previous talks, but if you don't remember, it's the idea that if the universe is filled with life, why haven't we found it yet? Which really lacks an appreciation for the fact that SETI has really only examined the tiniest fraction of the sky and spectrum of possible signals. Even though it did commence in 1960 with Frank Drake's Project Ozma, very, very little of the sky has actually been searched. But anyway, that misconception made it easier to argue that the program wasn't worth the continued investment. On top of that, there were interagency conflicts. NASA had to coordinate with the National Science Foundation and other funders, and SETI often got caught in the middle of competing priorities. And finally, some people have argued that there might have been a case of too much visibility, maybe too much lobbying. Because the SETI budget was actually quite small compared to other space science missions, it might have flown under the radar, not getting attention from Congress, like, like many science projects. But, because of people like Carl Sagan and his Cosmos show and SETI pioneers who used SETI as a tool for science communication, they kind of drew attention through their advocacy, and it became a political target at just the wrong moment. So in 1993, when Congress zeroed in on NASA's SETI program, it really just was an obvious target. So since then, most SETI work has been funded privately, and that's an important theme that you're going to notice throughout this talk, rather than through federal budgets. The cancellation of NASA's SETI programs wasn't about the science being bad. It was really more about how the science was perceived and positioned in the larger political and scientific landscape. So, oops, I skipped a slide. Oh, no, I didn't. Did I? Yes, I did. I guess I took that slide out. Well, what I was going to say was that now I'd like to transition to talking about how SETI transformed in the wake of the cancellation from NASA in the 1990s, and how in the early 2000s up to the present day, how the field has been adapting, and really how it's been specifically also being privately funded. It's really not a field that's funded by federal science. So after the high resolution microwave survey was canceled in 1993, it really could have been the end of the search for extraterrestrial intelligence in the United States. But instead, that setback created a new path forward. The scientists involved quickly realized that if SETI was going to survive, it couldn't rely on government funding. It needed to build an independent base of support. And that is where the SETI Institute comes into being. It was founded during those chaotic funding years in the 80s and 90s as a nonprofit. And the institution stepped up to become a central hub for SETI research. In fact, some people, when they hear SETI, they don't even think about the general field of the search for extraterrestrial intelligence. They think of the SETI Institute. And it became a home for scientists who wanted to continue that work outside of NASA. And again, it marked that shift into how SETI was funded. The SETI Institute began turning to private philanthropy, often from wealthy individuals, billionaires, tech entrepreneurs who were inspired by the search. And so one of the earliest examples from this kind of early stage of SETI's transition is what's called Project Phoenix, which picked up where NASA's targeted searches left off. It was kind of a transformed version of the high-resolution microwave survey. Project Phoenix was supported by donations from private sources, and it used world-class telescopes, again, like Arecibo and Parkes, to systemically listen to hundreds of nearby sun-like stars. And over time, this model of kind of billionaire-backed science became a hallmark of SETI. Figures like Paul Allen, who I'll talk about in a second, and then later Yuri Milner, who launched Breakthrough Listen, which we'll also discuss, made it possible to pursue ambitious projects that the federal government was no longer willing to support. So in this way, the NASA cancellation didn't end SETI, it just kind of transformed it into a field that was kind of powered by philanthropy and entrepreneurial vision. And there's pros and cons to this, and we'll get into it. But today, many of the biggest SETI efforts are directly tied to this model of private investment. So Project Phoenix showed that SETI could continue outside of NASA, but it also revealed a big limitation. The community was borrowing time on other, people or institutions' telescopes like Arecibo, right? That meant it was competing with all of the other priorities of astronomy. What SETI researchers really wanted was an instrument of their own, right? Kind of like how Barney Oliver had envisioned Project Cyclops, designed from the ground up for that continuous, flexible searching. That vision became a reality in the early 2000s with the creation of this telescope array, the Allen Telescope Array, or the ATA, which was funded largely by Microsoft co-founder Paul Allen. Again, that model of private funding. Sorry. So unlike the borrowed hours on other telescopes that Project Phoenix did, the ATA was built to give SETI its own designated home, a purpose-built facility that could scan the sky for technosignatures while also contributing to mainstream astronomy. And kind of like, again, like Project Cyclops, instead of a big, massive dish, it's made up of dozens of smaller antennas working together as an array. So Project Cyclops really inspired what SETI would look like in the 21st century. Pardon. So critically, while the Allen Telescope Array was taking shape, another revolution was happening in astronomy that completely reshaped how we think about SETI. And that's the discovery of exoplanets. It's kind of hard to believe now because we know that roughly every star in the sky has a planet. But for centuries, people wondered if planets around other stars existed at all. And there was no hard evidence for this. That changed again in the late 90s when astronomers discovered the first confirmed exoplanet orbiting a pulsar, which we learned about pulsars last time, but for those of you who don't remember, it's a kind of dense, rapidly spinning star. So these were bizarre worlds, not exactly what we expected, but they proved the concept that planets are not unique to our solar system. And then just a few years later, in the later 1990s, came the breakthrough that really electrified the field. Two astronomers, Michael Mayer and Didier Queloz, discovered a planet around a sun-like star called 51 Pegasi b. And this was the first detection of a planet around a star like our own. And suddenly the idea that there might be Earth-like worlds out there became very real. And for SETI, this was a game changer. Before, the search was just pointing at stars without even knowing if those stars even had planets. Now researchers could target actual planetary systems. And with that shift came a new language and new search strategies. Scientists began to talk about looking for things called biosignatures. You've probably heard that term before. Things like oxygen, methane, and other gases in a planet's atmosphere that might signal life at work on that planet. Alongside that, SETI researchers started talking about technosignatures, kind of a foil to biosignatures, evidence of technology itself, such as unusual radio emissions, laser flashes, or even large-scale engineering projects. And in fact, the word technosignature became a way for SETI to rebrand itself in the early 2000s. Instead of being seen as a risky alien hunting project, it could be framed as just being part of the broader and new and exciting field of exoplanet science. So just as astronomers were now looking for biosignatures, SETI scientists could look for technosignatures, and this parallel helped bring SETI into the mainstream of planetary science, kind of riding that wave of enthusiasm that came with the discovery of, entirely new worlds. So with that in mind, let's jump into what SETI looks like in the 21st century and what we're doing today to find ET. You can't talk about SETI today without talking about Breakthrough Listen. Sorry, allergy season. So Breakthrough Listen is the world's largest scientific program dedicated to searching for evidence of intelligent life beyond Earth. The program includes a survey of of the 1 million closest stars to Earth. So that is a huge survey it's doing. It scans the center of our galaxy and the entire galactic plane. It even looks for evidence of extraterrestrial intelligence beyond the Milky Way, listening to messages from about 100 of our closest galaxies. And again, it's funded by private philanthropy. The project began in 2016, was designed to last for 10 years, and it was paid for by about $100 million in donation from a private philanthropist. So Breakthrough Listen is kind of like the SETI project that's happening right now. Pictured here is a telescope. It's called the Green Bank Telescope in Green Bank, West Virginia. And this is one of the major telescopes they use. You can't really tell from that picture, but it's 500 feet tall. It's an enormous telescope, and it's doing this cutting edge searching. So the issue with Breakthrough, however, is that it's expensive. It's like $100 million. It's a lot of money. So another we try to get the billionaires' attention as much as we can, but you can't rely solely on that source of funding. So another creative way SETI scientists have managed to keep searching, even with limited resources, is through what's called piggybacking, or the piggyback method. So instead of building a telescope, like the ATA, and reserving it just for SETI, or trying to get time on other people's telescopes like the Green Bank telescope and use that for SETI searches, A piggybacking approach lets SETI kind of ride along on observations that are being made for other purposes. So, for example, when a big telescope like Arecibo was being used by other astronomers, say to just observe active galactic nuclei or look at black holes, a special SETI receiver could quietly collect that data at the same time. That way, SETI was essentially kind of listening in without competing for telescope time or paying the full costs of running a facility. And this method has two big advantages. First, it makes SETI far more affordable since the infrastructure is already funded by mainstream astronomy. And second, it lets SETI gather an enormous amount of data over time, since the telescopes are in constant use. And the trade-off, of course, is that SETI scientists using a piggybacking method don't get to choose exactly where the telescope is pointing. So they kind of have to work with whatever targets are being observed by others. But since we don't really know where to search in the first place, because we don't know what kind of life is out there in the universe, it's not necessarily a bad approach. So this is one type of method that's also being used today. One of the more imaginative ideas in SETI that's fairly popular with the scientific community is the search for what are called alien megastructures. The most famous of these is something we've talked about in previous talks, and it's called a Dyson sphere. This was an idea that was first proposed in 1960 by the British-American physicist and futurist Freeman Dyson. Dyson was at this time thinking about how an advanced civilization might meet its growing energy needs, right? As civilizations get bigger and bigger, typically they require more resources, more energy. On Earth, we capture a tiny fraction of the sun's energy with solar panels, right? And we use that to power our civilizations in some part. But Dyson reasoned that a really advanced species might surround its star with a vast array of collectors of like solar panels, essentially a swarm of like satellites or panels that could capture a large portion of the star's output. So to outside observers looking at this, much of the light of the star would look really weird. Instead of shining normally, much of its light would be blocked or re-radiated as waste heat in the infrared. And Dyson suggested that astronomers could, in principle, look for such signatures as a way of detecting ET. You'll recall, if you attended last talk, that Nikolai Kardashev had a similar idea of looking for super civilizations. And this is a very attractive idea because if you're looking for civilizations like ours that are pretty radio quiet in the grand scheme of things, it's going to be really hard, kind of like finding a needle in a haystack. But if super advanced civilizations with large structures do exist, they'd be the easiest ones to find, right? Because they'd make the most obvious signals. Nevertheless, for decades, the idea remained mostly in the realm of theory, or even in science fiction. But then in the mid-2010s, astronomers noticed something pretty strange in the data from a star now nicknamed Tabby's star, after Tabitha Boyajian, which is the scientist who led the study. There's a NASA artist conception up there in the upper right corner. This star showed dramatic, irregular dips in brightness, sometimes dimming by as much as like 20%, which is crazy. Something far too extreme to be explained by, say, like planets crossing in front of it. So naturally, this sparked a lot of public excitement and speculation that perhaps we were seeing the effects of like a Dyson-like structure in front of this star. You might have even, it made the news, you might remember from a number of years ago. So scientists took that possibility seriously, but as good scientists do, they also explored more mundane explanations. And over the following years, careful observations showed that the dimming was wavelength dependent. And what that means is that the star was being obscured more at some wavelengths or some colors of light than others. This pattern points towards dust, not a solid structure, since dust grains scatter light in a way that large objects like a Dyson sphere do not. So while Tabby's star turned out not to be evidence of alien engineering, it was still like a really great demonstration of how unusual astrophysical phenomena can attract attention in the context of SETI and give us an idea of like what it might look like if we ever did find evidence of an alien megastructure. Another concept that has its roots in the 1960s but is still being actively explored today are a class of imagined objects known as Bracewell probes. So a Bracewell probe is a concept proposed by the radio astronomer Ronald Bracewell as a potential method for interstellar communication. Instead of sending fragile radio signals across vast distances, which may weaken over time or go undetected if you're not looking at the exact right place at the right time, Bracewell imagined that an advanced civilization might send an autonomous robotic spacecraft directly to another star system. This probe would be capable of detecting signs of intelligent life, establishing contact, and relaying information back to its origin. Kind of like a space chat GPT, if you can imagine, that you could have a conversation with without having to wait the long time that it takes light to traverse the distance of space. So in essence, the probe would act as an ambassador for the species that left it there, programmed with knowledge of its creators and designed to communicate with whatever intelligent species it might encounter. And this is often, again, attractive because it bypasses some of the challenges of two-way communication across light years, such as long time delays, by allowing the probe to interact in real time. Now, again, this is purely hypothetical. It's an idea. But the concept has been influential in shaping how scientists and philosophers think about how first contact might actually occur. Because it's not too crazy out there. We can imagine ourselves doing that at some point, right? We already have kind of some of the capabilities of doing such things. So it seems plausible that an intelligent extraterrestrial civilization could also leave an artifact like that in our own solar system. So if these did exist in our solar system, where might they be, and how do we look for them? So one intriguing idea about where one of these probes might be hiding, if they exist, is in what's called Lagrange points. There's a picture on the right there, kind of illustrating what a Lagrange point is. They are special positions in space where the gravitational pull of the Earth and the Sun, or the Earth and the Moon, balance in such a way that an object can maintain relatively stable with very little energy to maintain its orbit. So they're basically kind of like natural parking spots in space. And so because of that, they're actually very attractive locations for human spacecraft. In fact, the James Webb Space Telescope is in a Lagrange point. And in theory, they'd be great locations for an alien probe that wanted to stay nearby without being easily noticed or taking much energy to stay there. So Lagrange points are one of the areas in our own solar system that SETI scientists are looking for evidence of extraterrestrial intelligence. Another fascinating idea is what's called a planet-planet occultation. So an occultation simply means that one object passes in front of another and blocks its light from our point of view. Astronomers use this technique all of the time. For example, as we learned last month, when an exoplanet passes in front of its star, from our vantage point, we see how the star's light dips slightly, and that's how we detect many exoplanets today. But with planet-planet occultations, instead of a planet crossing in front of a star, we're talking about one planet crossing in front of another, as seen from far. So here's where it gets interesting for SETI. In our own solar system, we regularly send spacecraft to other planets, like the Mars rovers, right? And to stay in touch with them, we often position orbiters around the planet, right? So the Mars rovers are on the ground talking to an orbiter that then relays the information from the orbiter back to Earth. So we're sending signals between the planets in our own solar system. This is something we've been doing for decades. So if another civilization elsewhere in the galaxy were looking at us very carefully, they would notice that sometimes the Earth and Mars line up from their point of view, and in those moments, there would be a detectable exchange of signals, Earth sending data to a Mars orbiter, the orbiter relaying it back. And it would be communication between planets that they'd be seeing. So some scientists have suggested that we can search for similar patterns in other star systems, places where two planets might line up in a way that any planetary communication between them could be kind of seen as a brief flash or signal. So this is a really clever approach that scientists are working on right now to see if we can see evidence of advanced civilizations kind of at our level of advancement, communicating between objects in their own solar systems. Another one of the more exciting and upcoming ideas for searching for extraterrestrial intelligence in our solar system is the concept of a lunar far-side telescope, a radio telescope that is located on the moon's dark side, which is the hemisphere that is permanently facing away from the Earth. This idea has been around for decades, with many design studies and mission proposals, but has not yet ever been fully realized. But there is actually hope that mission could finally launch even as early as this decade, to make that a reality. The reason the lunar far side is so appealing for radio astronomy and SETI in particular has to do with what's known as RFI, radio frequency interference. On Earth, radio waves from cell phones, satellites, airplanes, and all kinds of human technology are in the air. And this makes it extremely difficult to detect faint signals from space, especially signals that might come from extraterrestrial civilization. The moon's far side kind of acts as a natural shield. It is completely blocking all of the radio signals from Earth, providing the quietest environment in the inner solar system for listening to the cosmos. And interestingly, no American missions have actually ever landed on the moon's far side. In fact, only one country has ever put anything there, and it was China. China landed 2 lunar far side missions. All of our Apollo missions and robotic landers have touched down on the near side, which faces Earth. So the far side is really, again, this pristine site for a telescope where SETI scientists could make discoveries, out in the universe. So this is a very, very exciting proposition. My understanding is that there is a telescope called LFT, LIFT. I think it's Lunar Far Side Telescope, is what it's called. And they're actually hoping to launch that as early as 2028. So there's actually kind of another little bit of a race to the moon at this point, because SETI scientists want to get a telescope up there before anybody else gets up there and kind of ruins that pristine RFI environment. So there is kind of a race to get a telescope up there now. All right. So we've touched on this a little bit, but again, when we think about searching for life on exoplanets, which are again planets on orbiting stars other than our own, the first idea is usually biosignature, right? Gases like oxygen, methane, that might be produced by living things. But there's also an exciting SETI angle here, which is to look for technosignatures in atmospheres. And a fabulous example of this is industrial pollution. On Earth, humans have released chemicals like chlorofluorocarbons, or CFCs, you've probably heard that word a lot, into our atmosphere. These don't occur naturally in significant amounts, as far as we know. They're again, as far as we know, it seems like they're strictly the byproduct of technology. So if astronomers were to detect similar chemicals in similar abundances in the atmosphere of a distant planet, it'd be a pretty strong hint that something technological was happening there. Other possibilities of atmospheric signatures could be like unusual heat signatures or odd combinations of gases that really can't be explained by geology or biology alone. And the remarkable thing is that this is totally accessible to us. We're actually just beginning to have the tools to look for these kind of signals. The James Webb Space Telescope, which I just mentioned, and its successors, can analyze the light that filters through an exoplanet's atmosphere when it passes in front of its star. And that light carries a chemical fingerprint of the gases present. So right now, we're mostly using this method to study biosignatures. But this technique could also reveal technosignatures, and there's a lot of scientists right now who are working on trying to get these studies set up, looking for these technosignatures, whether that's industrial pollutants or engineered greenhouse gases or something entirely unexpected. And this could really represent one of the most direct ways we might be able to detect advanced civilizations, not from hearing them or eavesdropping on their signals, but just spotting the chemical consequences of their technology. And it's an approach that ties SETI directly to exoplanet science, using the very same tools, just with a different set of questions in mind. So this is also a very accessible way for SETI to do the search without having to, again, rely on building their own telescopes or finding private or federal funding. And finally, we can look for evidence of extraterrestrial intelligence, again, in our own solar system. Maybe many of you have seen the movie 2001: A Space Odyssey, where they find the monolith on the moon, and it's evidence of an ancient civilization that had visited our solar system before us. Sounds funny, but there are people, legitimate researchers at universities and other institutions that are looking for solar system objects, objects that might be all around us, kind of like Bracewell probes, that really may already be here. So the possibility could mean searching for, again, probes, artifacts, or spacecraft that have entered our solar system, or even objects deliberately placed here in the distant past, kind of like that monolith from 2001. Now, this is a controversial area because the vast majority of what we see in our solar system is perfectly well explained as natural objects, and asteroids, comets, dust, debris, but in recent years, a few discoveries have sparked renewed interest. In 2017, astronomers detected an object called Oumuamua, which was the first known interstellar visitor passing through our solar system. This means it was an object that we know came from outside of our solar system. And it also had, we knew that because of the trajectory of the way it passed through our solar system. It also had some unusual properties, its shape, motion, its lack of a comet's tail, so we didn't think it was a comet. And this led some to argue that it might be artificial, perhaps even like a spacecraft from another civilization. Now, most scientists disagreed, suggesting natural explanations, but the debate put solar system SETI kind of back in the headlines. In fact, one scientist, Avi Loeb from Harvard, started the Galileo project, which was specifically designed to look for these interstellar objects that come through our solar system. And actually, we just got visited by another interstellar object that's called 3I Atlas, which was initially observed by the Rubin telescope, was spotted. And like Oumuamua, it raised questions about whether interstellar debris could sometimes look strange enough to invite speculation about technology. So, while the consensus view is that these objects are almost certainly natural, especially in the case of 3I Atlas, it was just, we actually did some follow-up observations with the James Webb Space Telescope. You can see that down there. It has a comma, that's the gas output that we see on commas, so it's almost certainly a natural object. But still, the very act of detecting them has changed the conversation. For the first time, because of telescopes like the James Webb Space Telescope, like the Rubin telescope, we can actually study interstellar material passing through our solar system. And if we consider the spacecraft we ourselves have sent out, like the Voyager probes, for example, which have actually left our solar system and are now in interstellar space, it's not hard to imagine that civilizations elsewhere might have done the same as we have, and that one day their probe, could drift into our neighborhood. So this is why solar system SETI is both exciting and controversial. It challenges us to keep an open mind. Most discoveries will be natural, but by looking carefully, we also leave open the possibility of finding something extraordinary, evidence that we're not alone right here in our own cosmic backyard. So this is, again, a controversial but exciting to some area of SETI. And so with that, I'll conclude this little survey of how scientists are currently searching for evidence of extraterrestrial intelligence. I left a lot out because I didn't want to talk for more than 45 minutes at you, but we can talk more about it in the questions if you have questions. And thank you again for joining me on this fun romp through the history of the search for extraterrestrial intelligence.
If we're opening up the floor to questions,
Yeah.
I do have one, if that's all right.
Yeah, please.
Hi, my name's Aaron. Hi, Rebecca. Thank you for doing these. This has
Hi.
been really, really interesting to
Cool.
watch and listen to. But so you talked a lot about the history and things going on right now.
Mhm.
I just was wondering, like, let's say we find something. Let's say we get that radio signal that's for sure definitely not a naturally occurring radio signal, or we discover a superstructure. Oh my gosh, there's actually a superstructure way out there that we found a Dyson sphere. Holy cow.
Yeah.
What's next? What is there a plan? What do scientists want to happen versus what do you think might actually happen? Things like that.
Yeah.
Any sort of I mean, not necessarily speculation, but are there plans in place?
Yeah, fantastic question. Thank you so much. So there are and there aren't. So I actually just came back last week. I was in Pennsylvania for the Penn State Center for Extraterrestrial Intelligence actually holds a biannual conference where all the SETI leaders kind of come together and we talk about these issues. And this is actually a really hot topic of conversation right now. We call them post-detection protocols. And so we actually do have a set of post-detection protocols. They're not secret. You can look them up. The International Astronautical Union, sorry, no, the International Astronautical Association, the IAA. Um, they actually are the ones that have them on their website. So they exist. I say yes and no because they are not like sanctioned by any government. There's no international treaty. This is just guidance for scientists who happen to be doing this research. And also for scientists not doing this research, because the reality is, if you look at the history of astronomy, most discoveries happen by accident, right? We don't really know what we're looking for. We find something weird and then we figure out that it's a whole new class of objects we didn't know existed. And so the reality is that most people who are using instruments to look at the sky are not SETI scientists, right? They're astronomers, they're military officers, they're communications satellites people. And so the post-detection protocols are kind of meant to serve as a guidance for like, what do you do if you find a signal? And if you can look them up, and again, the general consensus is that it's really important to the community that this information is public, right? That there's no one's keeping any secrets. And there's also general consensus that it should be a democratic process for how to engage. Like it's not like, let's say, if the United States happens to find a signal, we keep it quiet, and then we, the United States, are the only ones who know about it, and we're the only ones who are going to send a message back. Nah, we don't we don't want that in the scientific community. That's not to say it won't happen, but that's we're trying to combat that with these protocols. They're actually being updated currently. There's a big, huge task force of scientists who have kind of gone through the proposals, tried to update them for the modern day, like covering topics like how do you responsibly disseminate scientific information to the public without causing a panic, for example. Um, and I'm actually I'm one of the people who is kind of editing and reviewing the kind of the new versions of the protocol, so I can't speak to them directly quite yet, but keep an eye out for that. And you can to address just your first point about uh, finding evidence that's definitely extraterrestrial. That's actually another issue we talk about in the community a lot, which is like, will we ever definitely, like, definitively know something is extraterrestrial in origin? Because that's the issue with a lot of astronomical discoveries and discoveries that happen at a great distance, is that we can find like a narrow band signal, right? Something that we don't think occurs in, in the natural world, and it is pulsating at super regular, like let's say primary numbers, and so seems obviously artificial. The reality is that we're always finding really strange things in space that we don't totally understand, like most recently, like fast radio bursts. Um, and so we can speculate that they might be artificial, but there is, like, other than like ET showing up on our doorstep or like sending like clearly film footage from another galaxy, like through, again, like a narrow band signal, it's like it actually might be really hard to ever really definitively say that we have found evidence of ET. And so that's another thing we wrestle with as a community. Like, how do you scientifically and responsibly talk about this with the public? It's a very long-winded answer, but this is a very rich topic of conversation in the SETI community.
No, 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 no. That was great. I could
Cool.
listen to you talk about it all day.
Cool.
Yeah, and
Careful, I
that's
can. I
something.
can.
Oh yeah, yeah. And I talk with my friend. We late night conversations about stuff like this, and we talk about how this sort of stuff, like, do you think that the aliens have been here? Do you think that this signal is XYZ? And I'm you
Yeah.
know space is so vast, like we don't really, when we talk about it, we don't even really comprehend how big
Oh
space
yeah.
is. And I talk about how the signals that we've sent out degrade over time, even though there's no
Yep.
no air and stuff, and like it has barely gotten anywhere
Yep.
close whatsoever to the next nearest star. Like, so it's just
Yeah.
the idea of contact across the cosmos seems so far-fetched and almost impossible to me that it's at this
Yeah.
point. I don't like to be pessimistic because it would be so cool to come into contact of any sort with some
Yeah.
sort of life out there. But yeah, just so big and so hard to do anything and transport even our own radio signals across space
Oh,
that
yeah.
it's mind-boggling to think about.
Yeah, there a good friend of mine, her name is Sophia Shake. She's a scientist at the SETI Institute in California. She actually just came out with a paper that's really cool where she basically figured out like what Earth's technosignature is. Like, so okay, you kind of mentioned how our signals degrade over time, and she did all the math to figure out like how far are our signals actually going in our solar system? Like, what are our most obvious signs of technology? And so I highly recommend if you're curious about this topic, you should look her up and her work. It's real neat stuff.
What was her name again?
Sophia Shake. Yeah, SETI Institute. She's great. All of her papers are worth reading.
Great, I will look that up. Thank you so
Cool.
much.
Any more questions?
Anybody else have anything for Rebecca? Okay, well, thank you again, Rebecca. We really appreciate it. It's very interesting and we learn something new every time. So thanks for joining us for our whole summer series.
Yeah, it was super fun. Thank you for inviting me.
And we will hopefully talk in the future about more interesting things.
For
Thank
sure.
you, Rebecca.
Thank
Thank
you.
you.
All right.